Hello everyone, welcome to my channel. In the last video, we talked about the motivation of difference in differences model and how it works conceptually. In this video, we will be talking about how the model works in a regression framework, or in other words, how you can estimate the difference in differences through a regression. And I will also leave the link to the conceptual video about difference in difference in the description below. Let's get started. So let's first make sure that we are on the same page about what difference in differences is. So let's take this example. Let's assume that we have a state A, which had this policy in 2014 in which they were providing coaching to their students in the schools. And let's say that we are interested in the impact of this coaching program on the test scores of students. Okay, so this policy, let's say, came out in 2014. So this is the data that we have for state A. So let's say that in state A in 2014, the test scores of students on average were around 50%. Let's say in 2016, this number went up to 60%. So we might be tempted to say that this 10% increase is the result of the policy, and the policy has led to increase in the test scores by 10%. But here's the catch. The thing is that the test scores could be just going on over time, or it could be a result of some national campaign or some other policy that was launched at the national level. That's where a state like state B, which did not have any such policy, can come very handy. So let me use a different color for state B. So let's say that for state B in 2014, their average test scores were around 60%. And let's say in 2016, they went up to 62%. Now we can see that state B, which did not have any such policy in 2014 or any other time, the test scores went up there as well by 2%. So what we do in differences is that we first take the difference for state A before and after, that is this thing which is 10%, and we also take the same difference for state B, which is this thing, that is 2%, and then we take the difference of these two differences, which is 10% minus 2%, and we say that this 8% is the likely impact of the policy on the test scores of students. Now the question is, how do we implement this model in a regression? Or in other words, how do we estimate this coefficient of 8% using data through a regression? I'll first give the main message, that is how you can use regression to estimate this difference in differences, and then I'll explain why exactly the model gives us this difference in differences. So the regression equation for this model is as follows, which is YIST, and I'll explain briefly in a minute what these terms are referring to. But here YIST is equal to constant alpha plus beta times state A dummy plus lambda times year 2016 plus gamma times state A times year 2016 plus the error term, which is epsilon ist. Let me explain what these terms are. YIST is the outcome variable, or in this specific example, the test scores of student I in state S in the year T. Okay. Alpha is the constant, beta is the coefficient for the state A dummy. And what is state A dummy? State A dummy is the variable which takes value for all the state A observations and 0 for all state B observations. So if you don't know, this is how dummy variables work. So for example, if you have a dummy for males, it takes the value 1 for all the males and 0 for females. Similarly, and just by the way, these things, these stars, which I've tried to create, but maybe they did not come out that way. are multiplicative symbols. This one too. Lambda is the coefficient for year 2016 dummy. So year 2016 dummy, as you can guess, this takes value 1 for the year 2016 and 0 for year 2014. And here I'm assuming that you only have 2 years of data, 2014 and 2016. Okay, this is gamma, which is the coefficient on the interaction of state A and year 2016 dummy. So this is a variable which takes value 1 for the observations in both state A and year 2016. So if it is state A and year 2014, this will take value 0. If it is state B and year 2016, it will still take the value 0. Epsilon is the error term, and for now we will ignore this error term. So let us see what will be the outcome variable for state A in the year 2014. So in this case, state A means that this variable will take value 1, and year 2014 means that this variable which take value 0, and similarly this interaction term will also take the value 0. So state A year 2014, our y will be alpha plus beta, because state A is equal to 1, right? This lambda term will be multiplied by 0 because year 2016 will take value 0. So this will not be there. And similarly, state A times year 2016 will also be 0 because state A is 1 but year 2016 is 0, and 1 multiplied by 0 is 0. So this will be for state A and year 2014, y will be equal to alpha plus beta. Let's take state A and year 2016. This thing will be equal to, will for sure have alpha, will also have beta because state A is equal to 1. Here we will also have lambda because year 2016 will now take value 1 because we're actually talking about year 2016. Since state A is equal to 1, year 2016 is equal to 1, and 1 multiplied 1 is equal to 1, we will also have gamma here. Okay, and as I said, we are ignoring the epsilon term for now. Okay, so what do we do in difference and differences? We take the difference first of state A of year 2016 and year 2014. So this thing will be difference for state A 2016 minus 2014. This thing will be equal to alpha plus beta will cancel out, so we'll just have lambda plus gamma. Now we can also think about the same terms for state B. So state B year 2014, this thing, so alpha will be there, and state A will take value 0 because we're talking about state B. Year 2016 will also take value 0, and this interaction will also be 0 because 0 multiplied 0 is 0. So we'll actually just have alpha here. And state B 2016 will have alpha. Let's see. So this variable is equal to 0 because we're talking about state B, but this variable is equal to 1 because you're talking about year 2016. So we'll have lambda, but we won't have gamma either because the interaction will be 0 because you're talking about state B here. So we'll just have alpha plus lambda. Now what is the difference for state B? We have alpha plus lambda minus alpha, which is equal to lambda. So again, just a reminder, what do we do in difference and differences? We take the difference for state A and we take the difference of state B and we subtract the two. So our difference in difference, or DID, will be equal to this term lambda plus gamma minus this term, which is just lambda. So we'll have this gamma. And as we can see, this gamma term gives us the difference in differences. So basically, if you want to estimate difference in difference through a regression, you will have to run this model. And in this, the interaction coefficient will give you the difference in differences, which in this case is gamma. So this is the coefficient you'll be looking out for. That's all for this video. Hopefully you found it helpful. Thanks for watching. See you guys in the next one.